What's going on, guys? Welcome to Rotor Riot and welcome back to Learn to FPV. Today we're going to talk about motor. So I'll run down the different specs of the motor and give you a few considerations to think about to help pick the right motor for you. So as far as specs, there's not a whole lot with motors. It's just KV, stator size, and then the overall dimensions or weight. I know a lot of you guys that have been in the hobby for a minute, you've already heard this 100 times, and I'm sorry, but there's new people that get into the hobby every day and they're not going to know what these numbers mean. I used to get this question a ton at the hobby shop I used to work at. So for stator size, this motor is a 2207. This is a 1106, 1408. You're always going to see those numbers on pretty much every motor. That's the dimensions of the actual stator. So it's not the dimensions of the entire motor, it's the dimensions of the stator. So the stator is the part that actually has the wires coiled up over it. The bell is the part that's going to have the magnets inside of it. And essentially what's happening here, you know how if you take two magnets with the same polarization, they push away, right? Well, each one of these, I think they're called poles, they're going to alternate so that it's always repelling it away and then one's pulling it towards, and they just keep alternating so it's constantly spinning around. So when you see 2207, what that's going to mean is that this is going to be 22 millimeters wide, 7 millimeters tall. It's very simple. Now for KV. KV is essentially the speed at which the motor is going to spin. So if it's a 2450 KV, the way that works is if you were to feed the motor 1 volt, it's going to spin 2450 RPM. And then you just times that by the voltage. So if you were to put a 3-cell battery on it, it's going to spin at a set speed. If you were to put a 6-cell battery, it's going to spin twice as fast. It's a pretty simple concept what KV is. There's some more technical specs that we'll get into later, but in general, and especially for a beginner, that's all you really need to think about when choosing the specs of the motor that you need. So when you're trying to pick the motor for you, here's some things that you should be thinking about. Firstly, there's price. In any different size of motor, you're usually going to find that there can be a range of prices. So sometimes one motor may be more than double the price of another motor. But there usually is valid reason for that, and not necessarily for everybody. Sometimes some people may go with the cheaper motor and it works just fine for their use. Other people, that cheaper motor is just not going to work as well. So some of the reasons why one motor is going to be so much more than the other is A, the materials used. So a lot of times if a motor is really cheap, it's made out of softer metals, it's going to bend easier, it's not going to be as durable. Another thing is the bearings they choose to use. Not all bearings are created equally. So sometimes you may get one little ding of a motor and then it runs really rough after that. Different companies are going to have different levels of quality control. So sometimes your cheaper motor, they may just kind of let things slide that were a more expensive motor. If it doesn't pass certain tests, they get discarded and they don't go out to the consumer. But there's definitely exceptions either way. Not every motor that's more expensive is really worth the extra money, and not every motor that's less expensive is not going to be good. So it's really just going to take some time and experience in the hobby and understanding what people are using and how well it's working, and trying things out for yourself to figure out what's going to work. Because like I said, if you go for a cheaper motor, it may not be made as durable, so you may be breaking them a lot, replacing them a lot. So over time, you're actually spending more. But maybe you're the kind of pilot that's just out cruising. You're not trying to really bash your quad. You're not crashing into concrete all the time. So those cheap motors that don't really take a crash well aren't being crashed very much. So they'll last you a long time. It really just comes down to your usage and what you need out of that motor. Another thing that can be factored in there is how much power that motor makes. So just because this motor is 2207 and another motor is a 2207 and they're both 2450 kV, due to some of the other factors that go into how a motor is made, they might not necessarily be the exact same amount of power. So if you're looking to go really fast, the cheaper motor in some cases may not make as much power, may not be as good for you. Another thing to think about is the brand of the motor. So just like anything else that you buy in the world, different companies have sort of different levels of trust of knowing that what they make is going to be quality, it's going to be fairly priced, it's going to last a long time, and they're going to stand behind their product and have good support. So you may find a motor that's really cheap. On paper, it seems like it has all the same specs, but it's some company that really no one's ever heard of, and if it's, you know, not a good motor, you're not going to be able to get any kind of support out of it. It's just something to think about. Another one is your choice of propeller that you want to use. You're typically going to pick the motor first and then pair a propeller with it, because props are a lot cheaper than motors, so it makes more sense to choose a motor and then find a prop that works well with it. But also, generally, like, the size of the drone and the prop kind of related. Like, we actually call the size of the drone based on the size of prop it can use most of the time. So you're going to hear, like, this is my 5-inch quad, this is my 6-inch quad, it's my little 2-inch. So knowing the size of propeller that you're going to use is going to affect what size motor you need for it as well. So to give you a little bit of idea on that, generally if you're going to use a 2-inch propeller, you're looking at anywhere from like an 1103 to 1106 motor. There's probably more than that. You could probably go a little smaller or a little bigger, but that's the general range, and that's going to apply for the rest as I go on. So for a 3-inch prop, you're in the 1306 to 1606 range. 4-inch prop, I would say like 1806 to 2204. 5-inch propellers, I would say probably about 2205 to like 2308. There's quite a bit of range in 5-inch. That's the most common prop, and you're going to find the most variations, the most different types of other equipment, so there's a range there. 6-inch, generally maybe a little bigger. You could probably go as low as like 2206 up to maybe 2408. So just to give you a general idea. So the size of the propeller and general size of the drone, that's going to dictate which size and which KV you choose. So generally, the bigger you go, the bigger the motor and the lower the KV. And vice versa, the smaller you go, higher KV, lower weight. You don't want to try to put a huge motor on a small propeller. It may seem kind of intuitively like that's going to give it more power, but that's not necessarily how it works. There's diminishing returns. You may not even actually find the KV that you would need in a huge size and a small prop, and it's just going to add unnecessary weight. So you want to stay generally in the range, and if you want more power, more speed, you kind of skew towards the high end of a bigger motor with a higher KV. And if you want more efficiency and longer flight time, maybe a little bit smaller motor, spinning a little bit slower. Motor choice can be a little tricky, and you can find sort of conflicting information, and you can just find conflicting results. There's a lot of variables that are going on. You have the weight of the drone, you have which type of prop you're using, you have which kind of battery you're using, and they're all going to play together. So while in some cases a smaller motor may be more efficient because it's less weight, so overall you're hauling less, you're pulling less power, should fly for longer. But maybe that motor, since it is small, it has less overall torque and power, and may struggle to swing that prop as much as a bigger motor could. So maybe in some cases a motor may be a little bit bigger, but since it has the extra torque, it struggles less to spin the prop, so it's overall efficient. It's really a fine balance, and it's all kind of just this equation where everything kind of works together. And sometimes it can just require playing around with different setups to find what's the most optimal for your setup. There's definitely sources online, like there's a site called Rotor Builds where people will post their setup on there. So that can be a really good resource for any of the components we're going to talk about in this series. If you're unsure of what to go with, you can kind of look at similar builds to what you want and then figure out what are people using. What's the most extreme on the low side, high side, you know, high price, low price. And it's a really good resource to get a feel for what's going to work for your setup. So for me personally, I kind of prefer a slightly bigger motor with a higher KV and then pairing that with a really lightweight and thin bladed prop. For me, that gives me the feeling of control because the motor doesn't struggle at all to spin the prop up or slow it down. It just feels crisp and locked in for me. Maybe other people will kind of prefer it totally different. Maybe they want the most aggressive prop out there on maybe a little smaller motor to save some weight. It just depends on the person. There's so many different combinations between propeller, motor, battery, and overall weight that it may just take time to figure out what's going to be right for you. So if you're really unsure, what I would recommend is look for something that's kind of middle of the road for your size drone. Pick a prop that's kind of like middle of the road, same across the board. If you go middle, you're in general going to have a good time. If you go to either extreme, it may not be what you're looking for. Okay, and lastly, I'm going to give you some of the other things that go into a motor, and I'm not going to go into too much detail on this because for a beginner, I don't think it's really as crucial. The main thing is just to get going. Get a motor that's not going to be so expensive that you can't afford to keep replacing them, because motors are probably the most common thing outside of propellers that you're going to replace all the time. They're out on the ends of the arms, they take hits, so stick with something that you know you can get it easily, you know you can afford to replace it. But some other things that go into account, you have the windings. So the windings is the actual wire that's going around them. I think you can find conflicting opinions here, but there's different types. Some are going to be multi-stranded wire, some is going to be like one solid strand wire. Some are going to look a little messy, some are going to look really clean. Again, you're going to find some people that say this is better, some people say that's better, but it's just something to know. You can do your own research into that. I don't really have too much opinion. I don't think about what does the windings look like or what are they made out of. I just fly the motor. If I like it, I like it. If I don't, I don't. Another specification that can play into how much the motor costs and how well it performs or how much power it can make is the air gap. So the air gap is how close to the magnets in the bell ride next to the stator. Now in theory, the closer that gap is, the more power the motor can put out. And to get it really close just requires more fine machining and fine designing. So a lot of times in a higher end motor, it's going to have a smaller air gap. I don't know if that's really crucial for a very beginner to be thinking about. It's not a huge deal, but it's just all these little things are going to add up to make a motor be more powerful, have better performance overall. Speaking of the magnets, there's also different types of magnets that go in these bells. Again, I'm not going into detail here, but just suffice it to say, some magnets are going to make more power, some are going to make less power. Some are going to be more expensive to source and put in the bell, some are going to be cheaper. Again, not crucial for beginners to think about, but it's a thing. There's different magnets in the motor, so there's reasons why some motors are more expensive than the others. This is basically what I'm trying to get to. And then the last thing I would say is some motors come balanced better than others. So balancing is essentially just to make sure when it spins, it's going to spin smoothly and there's not extra weight on one side that's making it oscillate. This is important because the motor and the prop are the only moving parts. So this is where all your vibration is going to come from. And to get a really nice smooth flying quad, you need very minimal vibrations. So maybe on some really cheap motors, they may skip or just don't do a great job on the balancing process. And maybe no matter how much you tune that quad, you're never going to get rid of the vibrations because the motors just have so much of it already. So how well balanced the motor is, that's another thing that's going to play into how well it performs and how much it's going to cost. So that's going to do it for motors. If you have any more questions about motors, definitely leave a comment and I'll do my best to give you a good answer. So with that, thanks for watching, and this has been Learn to FPV.